Yo, 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 yo. Hey guys, this is Mr. G, and we're going to talk about real numbers and sets of real numbers, okay? Or a set of real numbers, or different types of real numbers. So first, our key term is real numbers. So it's a set of rational numbers and the set of irrational numbers. Now, someone would always ask, okay, well, what would make something that's not a real number? And that is more in getting into high school level stuff, but an example of something that's not a real number is there are such thing as imaginary numbers, and we will learn about those, or you will learn about those later on in your mathematical careers. So first, let's just focus on real numbers. So here, you guys have this chart that really lays out all the categories and all the sets of real numbers. So we have two categories of real numbers. We have rational numbers and irrational numbers. Now, within those two categories, though, we have different sets. We have different subcategories, if you will. So what I mean by that is if a number is a rational number, it is possible that it is a whole number or an integer as well. Okay? So if it's a rational number, it could also be a whole number. It could be an integer. If it's irrational, it's just irrational. Now, here are a bunch of examples of rational numbers. These are examples of integers, and these are examples of whole numbers. Whole numbers, you guys, have to be positive. They're positive numbers that are not written as fractions or decimals. They're positive counting numbers. So 1, 2, 3, 4, 5, 6, 7. If as soon as you have a decimal, if it's like 1.2, it is no longer a whole number. If it's a fraction like 1/2, it's not a whole number. If it's negative, it's not a whole number. So whole numbers have to be positive. So maybe write that down inside your whole numbers box, or maybe write it down on the side. Whole numbers must be positive. That's really the only difference between whole numbers and integers, because integers also have to be whole numbers. However, integers can also be the negative counterpart as well. So integers and whole numbers really look very similar, but the difference is integers can be negative and they can also be positive. So make sure you include a couple positive numbers in here as well, because integers are also positive numbers. They're positive and negative whole numbers. So all we're doing today is we're just classifying these numbers. We're just saying, hey, is this number a whole number? Is it an integer? Is it just a rational number, or is it an irrational number? So whole numbers, positive numbers that are counting numbers, so they're positive whole numbers. Integers are positive and negative whole numbers. Rational numbers is everything else. So it's like these decimals that are repeating. It's fractions. It's negative fractions. It's positive fractions. It's terminating decimals. All of these are rational numbers. Now, integers are also rational numbers. And whole numbers are also integers, and whole numbers are also rational numbers. That's why whole numbers is in this inner circle here, because it is included in all these three other categories. So let's go through and we're going to name all that apply to each number. And then irrational numbers are really just imperfect square roots. Imperfect square roots, or imperfect cube roots, is really what we know about irrational numbers up to this point in time, and pi. So if I looked at the square root of 5, the square root of 5 is not a perfect square. So therefore, it is irrational. And I'm done. Once it's irrational, there's nothing else I can classify it as. So it's all over. We're good. Looking at B, negative 17.84. So negative 17.84 is not a whole number because it has this decimal with values after it. It's also not an integer for the same reason, it has a decimal. So, but it is a rational number, so I'm just going to put rational. Now for C, I have square root of 81 over 9. So what we want to do is we want to simplify this. The square root of 81 is 9. So I have 9 over 9. So some people say, well, that's a fraction, so it can't be a whole number or an integer. However, I want to simplify this even more, because 9 over 9 is really just 1. So because this is really just a fancy way of writing the number 1, that means that this is a whole number because it's a positive whole number. So it's a whole number, but if it's a whole number, then it's also an integer and it's also a rational number. Because whole numbers are part of rational numbers. Whole numbers are also a part of the integers. So if I were to name all that apply, this one's a whole number, it's integer, and it's a rational number. And of course, it's also a real number. All of these are real. I should have been putting that as well. They're all technically real. Okay. So what I want you guys to do is look at, let's see, 12 2/3 innings. How would you classify it for number 1 right here? It's hard to see it in this video. Sorry, I'll just erase this. Or maybe, yeah, I'll erase it because you guys should have it at this point. 12 2/3 inning. 12 2/3 inning is that an irrational, rational, integer, or whole number? Go ahead and answer that. And it's just rational, and it's also a real number. Because it has that 2/3. 2/3 is not a whole or integer. So the length of the side of a square that has an area of 10 square yards. So if I have a square, and the area of that is 10 yards squared. Okay, so that means I got to figure out, well, what is the side length here? Well, to find the area of a square, so let me actually draw a better picture because that is hard to read. I'll make this bigger here. So I have a square. The area of this square is 10 yards, 10 square yards. So that means a square, what we know about a square is that the side lengths are the same. So if I want to find the area of a square, I multiply the side length by itself because I'm just doing length times width. But a square, those are the same values. So to find the area of a square, I'm going to take that area, that side length, and I'm going to multiply it by itself. And that's equal to 10. Because I know if I take the side, multiply by itself, I should get 10. So really, this side length, because x squared equals 10, this kind of goes back to when we were learning about square roots. We said the square root of 9 equals 3. Well, that means also that 3 squared equals 9. That these go opposite directions. So if I know that some number times itself equals 10, if I want to figure out what that number is, I need to find the square root of 10. So the side length, this side length right here, is equal to the square root of 10. So that's the number that I'm looking for. Well, the square root of 10, do I know the square root of 10? And the answer is no. I can estimate what it is, but the square root of 10 is a number that's a decimal that goes on forever and it doesn't repeat. It's an imperfect square, which means it's an irrational number. But it's also a real number. Okay. So, we're going to tell whether the given statement is true or false. We're going to explain. I think you guys should try to answer A and B on your own. A and B on your own. And you know what? You can do this, all 3 of these on your own. So pause it, try it, see how you do. Okay, so first we have all irrationals are real numbers, and that is true. So everything we've learned about are real numbers, and irrational numbers are part of all of real numbers. So everything that we put as irrational is also going to be a real number. So that is a true statement. And that was my explanation. Instead of me writing it down, that was just me explaining it to you. No rational numbers are whole numbers. So no rational numbers are whole numbers. That is false. The reason why is all whole numbers are rational numbers. Like if I take the numbers 1, 3, 4, these are all 3 rational and they are also whole numbers. So these are both rational and whole numbers. Okay, so remember, all whole numbers are rational numbers. Okay. And then finally, identify the set of numbers that best describes each situation. So if I was talking about the number of people wearing glasses in a room, so we were to look in our classroom and figure out how many people are wearing glasses, it's going to be a positive number. I know that because we don't have negative people in the classroom. And it's also going to be a whole number because we're not going to say, oh, half of this person wears glasses. So because it's positive and whole, that means all the classifications is that it's going to be irrational. It's going to be a whole number. It's also an integer because all whole numbers are integers. And it's also, of course, a real number. Because it has to be a counting number that's positive. So 1, 2, 3, 4. So it's a whole number. And if it's whole, it's automatically an integer. It's automatically rational. And it's automatically real. All right. That's it. It's just classifying numbers. That's all we're doing. Okay? So things to remember. Integers are positive and negative. Whole numbers. Okay. Classify these two. And that's all I got for you guys. Thank you for watching. Gradius out.